The next example I wanted to look at was number 8. It's probably the next easiest. Again, you got to go back and look at those theorems. The one that you would use in this case is the same side interior angles. Some books call that consecutive interior angles. And when you look at your parallel lines cut by a transversal, same side means now you are on the same side of this transversal. They are still inside the parallel lines. So they're these two angles right here. These two angles are not going to be congruent. These two angles are going to be supplementary. They're going to have to add up to 180. When I look at the picture that you have up here, I somehow need to get this 118 measurement and help me with my numbers up here where the question mark is. When I look at your picture, what I see here is I see these whoops, that's off. Well, okay, I'm just going to redraw it. I see this parallel line with this one. These are your parallel lines. Here's your transversal coming in right through here. So this 118 that you have, that's right here, would be a same side interior with this angle right here. And they're going to be supplementary. So to find this angle that I have up top, I'm just going to take 180 minus 118, and that gets me 62. All right, and if that's 62, then I'm going to go back to, remember the thing where you had the linear pair and these two angles would form a straight line, so they'd have to add up to 180? You have the same thing going on up here, but it's not two angles, it's actually three angles. You have this little angle here, you have your question mark, you have this 90 degree, and you have this 62. And all three of those angles together are creating this straight line. That means that this 62 plus this 90 plus something else is going to be 180. So I would probably just take 180 and subtract these. If I take 180 and subtract the 62, I'm back at my 118, and then I have to also subtract 90, which would get me, I should have done my math earlier. I don't know. 90 minus 62 is 28. Is that right? 90 minus 62. Yeah, 28. All right. Okay, and this is your last one, and this is the trickiest one. The proofs are usually the trickiest ones, but what your proof on number 6 is asking you to prove those lines are parallel, and all those theorems that you have also have converses, which means it's flipped around. So instead of saying, hey, if I have parallel lines, then these angles are congruent, it goes the other way. If these angles are congruent, then the lines are going to be parallel. Or if these angles are supplementary, then the lines will have to be parallel. And so you want the converse theorems on this one to get to the lines that are parallel. So of these different ones, I think for the picture you have, you're probably going to be doing this one right here. If two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are going to be parallel. So we're going to try to get the consecutive interior angles supplementary so we can prove that the lines are parallel. Looking at your picture, they show you that angle 3 and 8, this angle 3 plus angle 8 are supplementary, and those are not consecutive interior. 3 and 6 would be consecutive interior. So if I could somehow show 3 and 6 are supplementary, then I could prove that the lines are parallel. And so to get 6 involved in this proof somehow, and to get rid of the 8, I'm going to look at 6 and 8. Well, 6 and 8 are your vertical angles. Now my pen writes terribly, so I'm going to probably just do a lot of abbreviation, but the very first thing you're going to do is grab this given piece of information and put it here, and then you're going to write your reason is given. And then I'm going to get that 6 and 8 relationship figured out. So I know that angle 6 is going to be congruent to angle 8 because vertical angles are congruent. See how terrible that is? Sorry. Okay. Now what that allows me to do is get this 6 involved in the problem that I need, because remember, I'm going to try to show that 3 and 6 are consecutive interior, and they're going to be supplementary because 6 is the same thing as 8. In fact, if 6 is the exact same thing as 8, if it's equal to that, then can't I just replace this with an angle 6 instead of an angle 8? And that would be your next step. You would go ahead and you would replace this measure of angle 8 with the measure of angle 6, since it's the same as that. And that's actually what you would write here then. You'd say, all right, I'm going to rewrite this measure of angle 3 plus measure of angle 6 equals 180. Now if you do that, what you have just done is you have just substituted this angle 6 in place of the angle 8. Okay, so you would have had up here that statement and you just replace that. That's called substitution, when you replace things that are the same. You just substituted. All right, we're getting there. Now, if angle 3 plus angle 6 equal 180, well, angles that add up to 180 are supplementary. This right here means that angle 3 and angle 6 would have to be supplementary, because that's what supplementary means. They add up to 180. Whenever your reason is, well, that's what they are, or that's what it means, that's a definition. The definition of supplementary says that these add up. If they add up to 180, then they're supplementary. It kind of depends on the teacher on how detailed your proof has to get. I guess I would go one more step here, and I would say that angle 3 and angle 6 are supplementary. And my reason is, well, that's the definition of supplementary. I just showed that they add up to 180. Now that's key. I just said that 3 and 6 are supplementary, and 3 and 6 are consecutive interior angles. Okay, if 3 and 6 are supplementary, that means my lines must be parallel. So I'm ready to jump into my last statement. I'm ready to say Q would have to be parallel to R, because and again, depends on your teacher on how fancy you want to write this. I guess we could write that whole thing that says if consecutive, okay, I write consecutive, some books say same side, whatever your book says, consecutive interior or same side interior. Angles, look at this, this is terrible. If consecutive interior angles are supplementary, then lines are parallel. I'll let you finish it out. That's bad, but then the lines are parallel. And that's your proof. All right, hope this helps. I love geometry, don't you?